Greetings! Welcome to the Euclidean Mathematics Center, Mathematics for Students by Students. Today, we will learn about the relationships between the lengths of chords, secants, and tangents. Consider the circle with chords BC and AD intersecting at point E by the intersecting chords theorem. If two chords intersect in a circle, the product of the lengths of the segments of one chord equal the product of the segments of the other. Thus, the measure of line segment AE multiplied by the measure of line segment EB is equal to the measure of line segment BE multiplied by the measure of line segment EC. Now, we have a circle with two secants originating from point A as shown in the figure. By the secant power theorem, if two secant segments are drawn to a circle from the same external point, the product of the length of one secant segment and its external part is equal to the product of the length of the other secant segment and its external part. Thus, the measure of line segment AE multiplied by the measure of line segment AC is equal to the measure of line segment AD multiplied by the measure of line segment AB. Lastly, consider circle with secant AD and tangent AC as shown in the figure. By the secant tangent power theorem, if a secant segment and tangent segment are drawn to a circle from the same external point, the product of the length of the secant segment and its external part equals the square of the length of the tangent segment. Thus, the measure of line segment AD multiplied by the measure of line segment AB is equal to the square of the measure of line segment AC. Consider the circle with two chords AD and BC as shown. If AE measures 6 cm, ED measures 4 cm, and BE measures 3 cm, what is the measure of EC? Using the intersecting chords theorem, AE times ED is equal to BE times EC. Substituting values, 4 times 6 is equal to 3 times the measure of EC. So, 24 is equal to 3 times the measure of EC. Dividing both sides by 3, we get that the measure of EC is 8 centimeters. Consider the figure given. There are two secants, AE measuring 15 centimeters and BE measuring 9 centimeters. The external part of AE is given to be 3 centimeters. What is the measure of the external part of BE? Notice that both of the seconds originate from point E, thus we can apply secant power theorem. AE times CE is equal to BE times DE. Substituting values, 15 times 3 is equal to 9 times the measure of DE. Hence, 45 is equal to 9 times the measure of DE. Dividing both sides by 9, we get that the measure of DE is 5 centimeters. For the last exercise, look at the figure with tangent AB and secant AD as shown. Using secant tangent power theorem, AD times CA is equal to AB squared. Substituting the values given with AD measuring 27 and AC measuring 3, we get 81 is equal to AB squared. Raising both sides by the power of 1/2, AB measures 9 centimeters. Thank you for watching the video. If you appreciate the lesson, don't forget to hit like and subscribe to get more math videos.